Every AI company wants more NVIDIA GPUs. They cannot get them. But the bottleneck is not the GPU, it's not the wafer. A few weeks ago I talked about the memory war. How HBM memory is the most contested resource in the AI race. This is still true, but here's what nobody talks about. Even if Samsung and SK Hynix tripled HBM production tomorrow, it would not solve the problem, because there's one step after the memory is made. One step where the memory chip and the GPU are physically joined together, and this step is even more constrained than the memory itself. It is something nobody outside the industry talk about. Something boring sounding, something most people have never heard of. It is called advanced packaging. And right now, it is the single most constrained part of the entire global AI supply chain. One company controls all of it. Their capacity is sold out through 2027, and the entire AI economy is waiting in line. I'm Diana and this is Chips Weekly, where I cover semiconductors, the technology behind them, and the geopolitics shaping the industry. Today I want to explain something that quietly became the most important topic in the semiconductors. Because for years, this chip industry was defined by one thing: how small can we make the transistor? That race is not over, but the constraint has shifted. The new question is not how small the chip is, it is how the chips are connected to each other. This is advanced packaging, and it has reshaped the entire industry. For decades, a chip was a single piece of silicon, one die, one package, everything in the same surface. That worked when chips were small, but modern AI accelerators have outgrown that model. NVIDIA's Blackwell GPU is too big to fit on a single die. It is larger than the maximum size of a lithography machine can print in one go. That maximum is called the reticle limit. So, the industry did something clever. Instead of one giant chip, they started building multiple smaller chips called chiplets and connected them inside a single package. The GPU on the one chiplet, the memory on another, the interconnect logic on a third one, all sitting next to each other, communicating at incredibly high speeds. That assembly process is advanced packaging, and the technology that does it best is called CoWoS. CoWoS stands for Chip on Wafer on Substrate. It was developed by TSMC. Here how it works. Multiple chiplets, usually a GPU plus HBM memory stacks, are placed on the silicon interposer. The interposer connects them with the microscopic wires that allow data to move between them at speeds that would be impossible on a normal circuit board. Then the whole assembly is mounted on a substrate and packaged as a single chip. Every NVIDIA H100, every Blackwell GPU, every Google TPU, every Amazon Trainium accelerator, they all use CoWoS. No CoWoS, no AI chips, it is that simple. Now here where it gets serious. In late 2024, TSMC was producing around 35,000 CoWoS wafers per month. By late 2025, that number jumped to roughly 75,000 to 80,000. By end of 2026, TSMC is targeting 120,000 to 130,000. The capacity increased dramatically in 2 years. That sounds like a lot, but it's still not enough. TSMC CEO C.C. Wei said it directly. CoWoS capacity is, quote, very tight and remains sold out through 2025 and into 2026. Morgan Stanley estimates that NVIDIA alone will need around 600,000 CoWoS wafers in 2026, about 60% of the world's total demand. The top customers have already locked in more than 85% of TSMC's CoWoS capacity, leaving less than 15% for second-tier AI chip makers, dedicated ASICs, and startups. If you're not NVIDIA, Google, Amazon, or MediaTek, you're essentially waiting for scraps. This is no longer a technical bottleneck, it has become a market entry barrier. So why does not everyone just build more advanced packaging capacity? Because it is hard. CoWoS requires fab-grade cleanrooms, extremely precise alignment equipment, and yield optimization that took TSMC over a decade to perfect. A single CoWoS line can take 3 to 4 years to build and qualify. Each new facility costs billions of dollars, and the yield matters enormously. If one chiplet in the package is defective, you have not just lost the chiplet, you have lost the entire package, including the expensive HBM memory and the GPU die. That is why TSMC dominates. They have the highest yields, the most experience, and they're the only ones at the scale needed for NVIDIA. But the competition is starting to move. Intel has its own advanced packaging technology called wafers and EMIB for the chiplet interconnects. EMIB is being seriously considered as an alternative to CoWoS for chips companies that cannot get TSMC's allocation. Samsung is investing heavily in its own 2.5D packaging. OSAT companies outsourced assembly and test specialists like Amkor, ASE, Spiel, and now taking on CoWoS workload from TSMC. TSMC is outsourcing as much as 240,000 to 270,000 wafers a year to these partners in 2026. And TSMC itself is exploring the next generation panel-level packaging, also called CoWoS. Pilot line completion is expected this June, mass production around 2028 to 2029. And here's where this becomes a Chips Weekly story. Most of TSMC's CoWoS customers are American, but almost all of TSMC's advanced packaging happens in Taiwan. The US has been pushing TSMC hard to build advanced packaging on American soil. TSMC has accepted. An Arizona advanced packaging facility is being accelerated, but it will take years. And until then, the most strategically critical step in producing every American AI chip happens in Taiwan, right next to China. This is a silent vulnerability at the heart of the AI economy. For 50 years, the chip industry was defined by Moore's law. Smaller transistors, more transistors. That story is not over, but it is no longer only story. Advanced packaging is now where the constraint lives, where the value is being created, and where the next decade of competition will be decided. TSMC owns this market today. Intel and Samsung are trying to catch up, and the entire AI economy is bottlenecked by how fast new packaging facilities can come online. The next time you read that NVIDIA is supply constrained, remember, this is not the wafer, it is not the design, it is the packaging step that nobody talks about, boring sounding, strategically critical. At the new battlefield of the high-performance computing. If you found this episode useful, subscribe. I cover the space every week. And let me know in the comments. Do you think Intel or Samsung can ever break TSMC's packaging monopoly? Or is it just another market where one company wins forever? I will see you in the new episode. And until then, stay curious, stay sharp, and stay chip aware.